Let's do the next problem in analysis of LTI system using Z transform. Okay, here the question is, consider a discrete time linear time invariant system described by the difference equation y of n minus 3 by 4 y of n minus 1 plus 1 by 8 y of n minus 2 is equal to x of n plus 1 by 3 x of n minus 1. Okay, so this is the equation. Assuming that the system is relaxed initially, obtain the unit sample response of the system. Unit sample response means the impulse response of the system. Okay, so let's do this question. Given y of n minus 3 by 4 y of n minus 1 plus 1 by 8 y of n minus 2 is equal to x of n plus 1 by 3 x of n minus 1. Okay, so now applying Z transform to the above equation. So we will get, so what is the Z transform of y of n? It is y of z, okay, minus 3 by 4. What is Z transform of y of n minus 1? It is z inverse y of z plus y of minus 1, right? And what is the Z transform of y of n minus 2? It is z raised to minus 2 y of z plus z raised to minus 1 y of minus 1 plus y of minus 2, right, is equal to, what is Z transform of x of n? It is x of z plus 1 by 3. And what is Z transform of x of n minus 1? It is z inverse x of z plus x of minus 1. Okay, so this is how we apply the Z transform, right? So now what I'm going to do is I'm going to apply my initial conditions, but here they said that assuming that the system is relaxed initially. Relaxed initially means then all the initial conditions are equal to 0. That is y of minus 1 is equal to y of minus 2, which is and is equal to x of minus 1. That is y of minus 1, y of minus 2, y x of minus 1 are all equal to 0. That's what it means. So therefore this equation becomes y of z minus 3 by 4 z inverse y of z plus 1 by 8 z raised to minus 2 y of z is equal to x of z plus 1 by 3 z inverse x of z, right? So this is how we do it. So now the procedure we all know after this, right? Now all we need to do is find the value of h of z, right? Or simply take the y of z common over here and x of z common, right? Just like how we did in all the LTI system problems, right? So we take y of z common, so it will become y of z into, here it will become 1 minus 3 by 4 z inverse plus 1 by 8 z raised to minus 2 is equal to, here I take x of z common, so x of z into, it will become 1 plus 1 by 3 z inverse. Okay, now I can find the value of h of z, right, which is y of z by x of z. So y of z by x of z is equal to 1 plus 1 by 3 z inverse by 1 minus 3 by 4 z inverse plus 1 by 8 z raised to minus 2. So this is the value of h of z, right? Now I need to find the value of h of n, right? To find the h of n, I cannot simply partially factorize this because I need the z to be in the positive powers. So here the z are all in negative powers. So what I'm going to do is I'm going to multiply both the numerator and denominator with z raised to z square, z raised to 2. So that means this will become, so this equation will become z square plus 1 by 3 z by, here it will become z square minus 3 by 4 z plus 1 by 8. Alright. The reason I'm doing this is because only applying this only, then I can easily partially factorize this, right? In other words, h of z is equal to, maybe I can take z common over here, so it will become z into z plus 1 by 3 by, here it will become z square minus 3 by 4 z plus 1 by 8. Okay, so now in order to apply partial fraction, I need to partially factorize the equation h of z by z, right? Then only I can apply my partial fraction method, right? So therefore, dividing this equation by z, you will get h of z by z is equal to z plus 1 by 3 z plus 1 by 3 by z square minus 3 by 4 z plus 1 by 8 minus 3 by 4 z plus 1 by 8. Okay, so this is how we do the question, right? So now I need to factorize this, right? So how can I factorize this? I need to find the two numbers that by adding those two numbers I should get minus 3 by 4, and on multiplying it I should get 1 by 8. Okay, so which are the numbers? So the numbers that come to my mind is, immediately it will become 1 by 2 and 1 by 4, right? Minus 1 by 2 and minus 1 by 4. Yes, minus 1 by 2 and minus 1 by 4, because minus 1 by 2 plus minus 1 by 4 is minus 3 by 4, and minus 1 by 2 into minus 1 by 4 is plus 1 by 8. So the numbers are minus 1 by 2 and minus 1 by 4. So it means this can be factorized as h of z by z is equal to z plus 1 by 3 by, this is z minus 1 by 2 into z minus 1 by 4. Okay, so now I'm going to partially separate these terms. So this will become a by z minus 1 by 2 plus b by z minus 1 by 4. Okay, now I need to find the value of a and b. So a is equal to, so here the denominator of a is z minus 1 by 2 is the denominator. So in this expression I will remove that factor z minus 1 by 2 and write the remaining expression. So that is z plus 1 by 3 by z minus 1 by 4. Yes, after removing this factor, only these two factors remain. Alright, now and here z minus 1 by 2 is equal to 0, therefore z is equal to 1 by 2. So therefore I'm going to substitute z is equal to 1 by 2 in this expression to find the value of a. So it will become 1 by 2 plus 1 by 3 by 1 by 2 minus 1 by 4, which is, here it will become 5 by 6, right? 5 by 6 by, and here it is becoming, here it will become here into 2, so 2 minus, so here it will become 1 by 4, right? 1 by 4, or here you will get as, so if you want you can divide this, so this will become 3 and this will become 2, or otherwise this is nothing but 10 by 3. The value of a is 10 by 3. Okay, right? So the value of a is 10 by 3. Next, I'm going to find the value of b. So to find the value of b, same procedure. We substitute the value of, we remove the factor z minus 1 by 4 from here. So I will get z plus 1 by 3 by z minus 1 by 2. Okay, and then I substitute the value z is equal to 1 by 4. So z is equal to 1 by 4. So I will get 1 by 4 plus 1 by 3 by 1 by 4 minus 1 by 2. Okay, and 1 by 4 plus 1 by 3 is 7 by 12. 7 by 12 by, here it is minus 1 by 4, right? Minus 1 by 4. Okay, so maybe I can cancel this 4 and this 12 will become 3. In that case, the equation will become minus 7 by 3. Minus 7 by 3. Therefore, the value of A is 10 by 3 and the value of B is minus 7 by 3. Substitute that over here. You will get h of z by z is equal to 10 by 3 into 1 by z minus 1 by 2 minus 7 by 3 1 by z minus 1 by 4. Okay, now this preserved z can be put in the numerator so that I can find the inverse easily. So h of z is equal to 10 by 3 into z by z minus 1 by 2 minus 7 by 3 z by z minus 1 by 4. Okay, so now I can find the value of the h of n, right? H of n is equal to 10 by 3 z inverse of z by z minus 1 by 2 minus 7 by 3 z inverse of z by z minus 1 by 4. Okay, in other words, h of n is equal to 10 by 3. The inverse of this one is nothing but 1 by 2 raised to n u of n minus 7 by 3, and the inverse of this is 1 by 4 raised to n u of n. So this is your final answer. Okay.